All right. In the last section, you learned how to do systems of equations. Is that what we did last time? With substitution and elimination, right? Okay, we're also going to continue solving some things that are linear, but they're called linear inequalities. So we're going to look at it, how to do it algebraically, how to do it using a graph, and then of course there's no real x-intercept, it's just where it crosses the x-axis, and then the double inequalities. So we're going to finish this up today. So let's just go ahead and get started with it. Page down. All right, so here's what the first slide says. It says, do you understand what an inequality is? Do you know what an inequality is? So here's all you need to know. When you're looking for the word inequality, here are my symbols. That's one of them. What did I just write on the board? Less than. What about this one?
Less than or equal to.
And the next one? And the next one? Okay, and this very last one, you won't use it a lot, but it does exist. What's the last one called? Not equal to. That's exactly what that one's not equal to. You got an equal sign with a slash through it, it means not equal to. So these are all your inequality symbols. So if in my math lab it says write your answer using inequalities, it wants one of those symbols in the answer. So you got to use it if it says write it in inequality form. So that's all that statement was, just making sure you understand what inequalities are. And so when we solve them, we're going to get a set of numbers, meaning your answers could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or your numbers could be 1 to infinity. So it's just saying your solution is going to be a solution set. So it'll be a set of numbers. In the past, when we've solved equations, we only got one number or 1 point. This time you may get a set of numbers as your answer, so they're calling it a solution set. I'm going to also show you from bullet 2 and 3 how to write it in interval notation, how to write your answer in interval notation, graph notation, and inequality notation. There are 3 separate ones. I'm going to write all 3 of those on the board so you can see them. Okay? You're going to be asked in the homework to write your answer in maybe 3 different ways. One's inequality, one's interval, and one's called graph. So I'm going to show you all 3 of those. So with that said, I'm going to go to the next slide. All righty, so let's do the first one here. All right, it says solve the inequality. Why is it called the inequality? Because it has a less than symbol in it. Solve the inequality algebraically, and then it says graph the solution on the number line. So when you hear them saying graph, they just want you to use the number line. You're not even going to have to use decimals for this. All righty. So let's go ahead and start solving this one. So I have 3x minus 7 is less than or equal to 5 minus x. Now I want to solve and get x by itself. Now when there's a less than or greater than symbol, we always want x on the left. Always. I know before when you got an equal sign, you can do it x on the left or the right, don't matter. Whenever it's got an inequality symbol in it, I always want the x on the left. Always, 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 always. Alrighty? So now, what should I do first if I'm trying to get x on the left? What can I do? There's a couple things I can do. What can I do? I can add what? I can add x to both sides. I'm going to add x over here. The x's over here on the right are going to cancel out, right? Yes. Okay, so those are gone. And so now I have 4x, because 3x plus 1x is 4x. 4x minus 7 is less than or equal to 5. What should I do next? I'm still trying to get x by itself. Add 7 on both sides. So now the 7's and negative 7 is going to cancel. So now I have on the left side, I've got 4x is less than or equal to 12. Okay? Do I have x by itself yet? Divide both sides by? Okay, so divide this side by 4, divide that side by 4. X is less than or equal to 3. Now, you have just solved that inequality. The solution is x less than or equal to 3. Okay? Is this called an inequality statement? Yes, because it has a less than symbol in it. It's called an inequality. See, in the homework, when it says it wants you to solve this and write it in inequality form, it wants this answer. X is less than or equal to 3. Just type it just like that. I should have wrote it on the board so I could push it up. I did not. All right. It's also going to ask you to write it in graph form. Notice it says graph the solution. Graph form, you have to have a number line. So I'm going to put the number 3 on my number line. Ready? I'm going to put the number 3 on my number line. Just count wherever it is. 0, 1, 2, 3. There's my 3. Now, it says x is less than or equal to 3. What that means is x can be any number less than or equal to 3. Can x be 1?
Yes.
Yes. Can x be 2?
Yes.
Can x be 0?
Yes.
What about negative 15? Some of y'all said, y'all, I caught you. Negative 15, is it less than 3?
Yes.
Oh, yeah, so it can be negative. So any number less than 3, so on the graph, should I be shading all the numbers less than 3?
Yes.
Yes, so this arrow, or I should say this less than symbol, points in the direction that you should be shading. So if it's a less than symbol, it points to the left, you should be shading to the left. Does that make sense? Mm-hmm. Whichever direction that symbol is pointing, that's the direction you should be shading. Do I shade forever? Yes. Because it doesn't say stop at a number, does it? No, so we're going to shade all the way on this side forever, which means that I'm including this arrow at the very end of my graph. Okay, did it say to include the 3? Could 3 be part of the solution? Yes. It says less than or equal to 3, so I include the 3. To include the 3, either you use a closed circle or a bracket. Most of the homework is going to use a bracket. So you see me, I put a closed dot or a bracket. Means to include or equal 3. This is called the graphical notation. This is how you graph this. You're not going to need Desmos for this. The homework will give you 4 different options for the graph, and you pick the right number line. Okay? Question? So I gave you one notation. You got 2 notations. I'm sorry. You got the inequality notation for how to write it. You've got the graphical notation for how to put it on a number line. The last notation is called interval notation, where we use brackets and parentheses. Okay? The easy part about this is when you have the number line already, it's easy to write the interval notation. Because whatever symbol you put on the number line, you're going to put the same symbol in the interval notation. So did I use a bracket? So I'm going to use a bracket for interval notation. The bracket opens the same direction that it opens on the number line. So it opens going facing the left. So I'm going to open it facing the left. What number did I put that bracket on?
3.
So I'm going to put a 3. I'm going to put a comma. How far does this go? This number line? Infinity. So I'm going to put, which infinity? Negative or positive? Negative infinity, and you always close the infinity symbol with a parentheses. So you've got all 3 notations. You've got inequality notation, okay, which is this one. So this is called an inequality. You've got the graph notation, and now you've got the interval notation. All 3 of those, they can ask you in the homework to write it each one of those ways or one way at a time. It could ask you for either one. Questions? Again, the graphical notation is just a number line, so there's nothing special about the graphical notation. I want all the numbers that are less than. Now, let me ask you a question since we are here. We've already worked it out. This solution that we just got, it just says, if I plug in any number less than or equal to 3, it's going to make this side less than that side. See what it says, 3x minus 7 is less than or equal to 5 minus x? It's just saying, what numbers can I plug in that's going to make that a true statement? What numbers can I plug in? Well, let's try some numbers. I just want to prove to you that that's why we got the answer that we got. So here, I'm rewriting the inequality statement that we originally had. In the place of the x, Can I put a 3, a 2, a 1? All right, let's just pick a number. What number would you like for me to plug in? Put in a 3? Okay, let's see if 3 works. So everywhere there's an X, I'm going to erase and put a 3. All right, so I'm going to put a 3 right here. Over here, I'm going to put a 3 right here. All right, what's 3 times 3? And what's 9 minus 7?
2.
All righty, and what's 5 over here? 5 minus 3 is how much?
2.
Is 2 less than or equal to 2?
Yes.
I know it's not less than, but is it equal to? Yes, it is. So that makes this true. It's got to be either less than or equal to, so it meets that condition. All right, well, let's try another number. What other number should I plug in? Try 1?
Yeah.
All right, let's try 1 and see what happens if I plug in a 1. All righty, what's 3 times 1? 3, okay. And what's 3 minus 7?
4.
Negative 4? Okay. You said negative 4. What's 4 minus 1? Excuse me, I'm sorry. 5 minus 1. 4. All righty. So now when I got my statement down, is negative 4 less than or equal to 4?
Yes.
Is it less than?
Yes.
Yes. So does it work? Does our solution work? Yes. We were just proving to you that the solution actually does work. Okay, questions? All righty, so here is, we just did it on the graphical, we did the graphical number line, so we're good with that one. Here's the next slide. It wants us to actually do double inequalities. So double means what? What does the word double mean? 2 of them. So instead of 1 less than symbol, how many we gonna have? 2 of them. So we're gonna follow a similar method, but this time we're gonna have 2 less than symbols. So let's go on to the next one so you can see the double inequalities. Ah, it has 2 less than symbols in it. Anybody still working on what's on the board right here? No? Okay, I'm gonna pull this down. I wish I had pulled it down further. All righty, so I've got 17 less than or equal to 3x minus 5 less than 31. All righty. Now, since you have 2 less than symbols, your goal now is to get the x by itself. Guess where?
On the right.
Right, left, or middle? Which one do you think?
Middle.
Middle. We want to get the x by itself in the middle. It's always got to be in the middle between both of those less than symbols. So it's got to be in the middle. So that's our goal. Get it by itself in the middle. Everything that you do to the middle, guess what you got to do? On the left and the right. Okay. So in the middle, I'm going to add 5. And because I'm going to add 5 in the middle, guess what? I'm going to add 5 over here on the left, and I'm going to add 5 over here on the right. Okay? Now we're just going to do the math like we typically do. Do the negative 5 and positive 5 cancel?
Yes.
Okay, so that's gone. So what's left in the middle? 3x, okay, alrighty. On the left side, I've got 17 plus 5, which is 22. And I've got 31 plus 5 on the right, which is?
36.
Do I have x by itself in the middle?
Yes.
Is it totally by itself? Okay, what should I do? Divide by 3. So since I'm going to divide the middle by 3, I got to divide the left and the right by 3. So now x is now by itself in the middle. What's 36 divided by 3?
12.
12, okay. And then 22 divided by 3, it can't be reduced, so you got to leave it as a fraction. It goes in there 7 point something, which is fine. Now, what format is your answer in? Is it inequality, is it interval, or is it in graph?
Inequality.
It's got its less than symbol, so it's in inequality notation. Now we're going to do the graphical notation for this. Alrighty? Now, here's what you have to remember when it comes to graphical notation for double inequalities. These symbols that you see, when you see a less than or equal to with an x in the middle, and it could be 2 equal signs, doesn't matter. When you see this, shorthand words for this is in between. So when you see this, when I'm saying when you see this, it means in between. So I want you to shade all the numbers where? In between those 2 numbers. Okay? Alrighty, well, 22 divided by 3 is approximately what, 7 point something? So right here, I'm gonna put 7.3. I forgot exactly what it was, but it's the same thing as 22.3, which is approximately 7.3 something. Alrighty, where's 12 gonna go? Over here somewhere. Here's 12. I want to shade everything in between. Let me scoot this over so it looks like where I wanted to put it. This is 22.3, which is approximately 7.3. Alrighty, I want to shade everything in between. So here's me shading everything here. Alrighty, now question is, do I put a bracket or do I put parentheses on those numbers? Now right here, do you see this equal sign? So guess what? I'm gonna put a bracket right here. Because we're doing in between, the brackets gotta face each other. The parentheses and brackets have to face each other. So this one is gonna open that direction. Now this one, does it have an equal sign underneath it?
No.
No, so I'm gonna put a parentheses. I shaded everything in between 22/3 and 12.
So if it doesn't have an equal sign at the bottom, we have to have the parentheses.
Correct. If there is no equal sign, you have to use parentheses. If there is an equal sign, you have to use the bracket. Okay? Now the easy part is, we just did which notation? We did inequality. What notation was this type? That was graph. What's the last one we're going to do? Inequality. Excuse me, interval. The interval notation is the very last one we're going to do. Well, the easy part is, once you graph it on the number line, you literally just write the same thing. Bracket, parentheses, 22/3, comma 12. Done. That's why it's easier if you go ahead and graph it first, then you know exactly what to put for interval notation. If you graph it first, you know exactly what to put for interval notation. Put a bracket up here, bracket comes down here. You put a parentheses over here, parentheses come down. Two numbers go in the middle. That's it. Questions? Yes.
So why did it stop at 22/3?
Why did I put the bracket here?
Yes, I know you have to do it in between, but I don't understand why.
You can only put the brackets on whatever this number and that number. You can only put these symbols on whatever this number and that number. You can't put no other numbers.
But in the last one,
Mm-hmm.
we went,
Because look at the last one. Now look at the difference. This one has how many symbols? How many inequalities? 2. So always it's going to be shading in between two numbers. If there's only one inequality symbol, we're not going to be shading in between two numbers. We're going to shade one number and then the other direction all the way forever. All the time. When there's just one symbol, you're either going to shade all the way forever on this side or all the way forever on that side. So one of them is always going to, the type that only has one inequality symbol, always going to have an infinity symbol. Somewhere in your answer is going to be an infinity because it never stops. Because I said we could pick all the numbers less than 3. Can I count forever for all the numbers less than 3? -1,000,000, -2,000,000, -999,000. So I'm never going to stop. So this has to be an infinity symbol. It will never be in between like we did with this one. What are you thinking?
I understand the difference, I just don't know why it has a line under it.
Why
It's not
wait,
represented.
why this 22 has a line under it?
The inequality sign, less than or equal to?
This one?
Yes.
Why I did have an equal sign under this one and no equal sign under that one?
Well, no,
Okay, I'm listening, go ahead.
I don't see how it's represented by that graph if it's saying or less than.
Like the zero distinguishes less than.
She's saying that, I think what she's saying is that she's not understanding why that's represent, the 22/3 is representing less than or equal to.
Okay, so what I really want to make sure will let you understand is this whole thing together says in between. So don't try to look at it as pieces, like Don't try to say, oh, okay, there's a less than symbol over here with this 22/3. Are you trying to break it up and see it as pieces? Don't look at it as pieces. You gotta see this as the whole thing. Whenever you see two less than symbols with an X in the middle, it's in between. Don't try to break it up and look at it as this half and then that half. Because then it makes it not make as much sense.
Okay. Will
Yes.
it always have an X in between those two?
Yes, if it's double inequality, it will always have an X in between. If it's double.
What if it, oh,
Now, what could happen is, could it have this? It could, but your answer can never end like that. Your final answer has to always have less than symbols in it. Your final answer always has to have less than symbols. So what's wrong if you do end up with an answer that looks like this? You're like, I done worked all of this out. I still got greater than symbols in it. What am I supposed to do? If you end up with an answer like this, literally twirl your problem around. When I say twirl, I mean literally twirl it around. Literally. So here's an example. Here's an example of one that looks like this. Here's what you might have. That's an answer that you will find that answer somewhere in the homework. And you'll be like, I know I got the right answer. Why they keep marking it wrong? Because it will never accept the answer with greater than symbols. It will only accept it with less than symbols. Only. In between only works with less than symbols. So if you have an answer like this, and I say, I want all the numbers in between 5 and 2, do you say it like that? Or do you say, I want all the numbers between 2 and 5? So the smaller number has to always come first. So you got to switch this around and turn it. So when you twirl it, again, when I say twirl, I literally mean twirl it around. The X is going to stay in the middle when you twirl it. The 2 is going to go over here. This symbol is going to go where? Right here. So this is going to go here, and this one is going to go there, and the 5 is going to go there. So literally twirl the problem around. The smaller number has to be first. Yes.
Because you're saying that it doesn't make sense the first way. 5 is not greater or less than 2. Is that what you're saying?
I'm saying that 5 is not less than 2. It's
Right.
not. But I don't want you to read it in pieces like that. This is still an in-between problem. I just don't want you to say it like 5. How many numbers between, or what numbers are between 5 and 2? We never just logically say it like that. So it doesn't even make sense to say it like this. Bless you.
thank you.
But I understand what you're saying. 5 is not less than 2. It's not. But they don't have no less than symbols here. So I can't say that. You see what I'm saying? These don't have less than symbols, so I can't say less than. This not even written properly.
So in the homework, you just turn it around? And
Literally, when you get to your final answer, if your final answer looks like this, literally twirl the problem around immediately. Don't do anything else to it but twirl it around.
And then solve it.
No, solve it first. I'm saying do all the math that we did, dividing everything by both sides, adding whatever you're going to do, all the work till you get to right here. And if you get right here and you still got greater than symbols, twirl the problem around.
And that's twirl it around before you put it in my math.
Correct. Because if you put it in my math lab with the greater than symbols in it, it's going to mark it wrong. Yes.
But through this whole thing, we never even changed the symbols at all.
You didn't have to change the symbols. Why? Good question. We didn't have to change the symbols at all in this particular problem. Why? So let me give you an easy one for us to practice. All right, if I say I want negative 3x is less than or equal to, let's say 27. The goal is to get x by itself on the left. There's only one inequality symbol. Don't have doubles, it's just one. So, what should I do to both sides? Divide by negative 3. Well, guess what happens when you divide, when you have a less than or greater than symbol and you have to divide by negative? What happens to the symbol?
You gotta change it. to
It
the
changes to the other direction. This only happens if this number is negative and that number is negative. Don't matter if it doesn't matter if this had been a negative and that one wasn't. The only time the symbols flip is when these bottom numbers right here, when you're dividing both sides by a negative number.
So we're automatically supposed to know that?
Yes. Yes. So now you're going to switch the symbol from now being less than to what? greater than or equal to. So now you should have a note that says flip the symbol or switch the symbol, whatever word you prefer. Switch, flip, no matter. If you're dividing by a negative. So switch if dividing by a negative. Okay, so now my answer is gonna be -9 right here. 27 divided by -3 is -9. So now the solution is all the numbers bigger than or equal to -9.
But it makes sense though.
I'm confused with that.
Why? Tell me what you're thinking.
I-
I wanna know what numbers can I plug in to this equation, inequality, that's gonna make this statement true. And it's saying I can only pick numbers bigger than or equal to -9.
So we flip the greater than sign
Only when what?
when you divide.
When you're dividing by a negative symbol. Anytime you're dividing. If you had been dividing by a negative symbol over here somewhere, a negative, like if these two had been, all three of these had been -3s, guess what would have happened?
You still have to flip.
I would have flipped them. I would have flipped them. Now, even though I said they can't stay like that, you would have had to flip them back. You got what I'm saying?
Yeah.
Your final answer can never have greater than symbols here. So in the process of working this problem out, if you had some negative signs and had to flip it, after you did all your work and got down to your answer right here, flip it back. You gotta work it out first. You gotta work it out first. You can't flip. You just see what I'm saying? If you divide by a negative, you gotta switch the symbol. But when you get to your final answer, you can't leave it with greater than symbol, so you have to flip that one back. You have to twirl it back around. Yes, ma'am.
So you don't have to flip back to black, only when you got two of them. But you can leave it like that.
Yes, you can leave this one. This one's fine.
But it's single.
Right.
But
It's a
it's
single, only one less than, greater than symbol. You leave it just like this. It don't matter. You can just only flip if it's negative. But if you have it over here and you flip it to greater than symbols after you do all your work, flip it back. And I don't mean flip the symbols back. I mean twirl. Twirl. We're twirling. This is a twirl, okay?
I'm glad she asked that question. I know.
Okay, what are we thinking?
Can we do one more?
We put it on another one.
Yep, so let's put this one on the number line.
Can we do, problem off of my math lab?
Of course we can. So again, 2 of the problems off of my math lab are gonna look like these next 2 word problems. So I need to do these 2 word problems that you see up here. All right, -9 is on the number line right here. I wanna shade everything greater than. Do I put a bracket or a parentheses on -9?
Bracket.
Bracket, because it has the equal sign. And then, do I shade forever?
Yes.
Yes. In the direction that that symbol is pointing, which is greater than. All right, so that's graphical notation. Here is integral notation. Put a bracket, -9, comma, all the way to where?
Infinity.
Positive infinity, close infinity with a parentheses. Alrighty. Last couple that we need to make sure we do, just to make sure you understand it from a homework perspective. Alrighty, let's see what it says it wants us to do. I'm gonna push this board up so you guys can still see it and pull this white one down so I can use it. Alright. According to data from the National Vital Statistics Report of 2010, the marriage rate, okay, marriages per thousand, we're just looking at it for every group of thousands. It can be described by Y. So the marriage rate is Y, and Y is equal to -0.146x plus 11.074, where X is the number of years after 1980. All right, it says, for what years does the model indicate that the marriage rate is above 9 marriages? Okay, above in math means what? Greater than, less than, or not equal to, which one? Greater than. So I'm going to take the equation that they gave us. What's my equation? -0.146x plus 11.074. And they want to know when the marriage rate is what? Above what? Above what? What does it say? Above what? 9, so I'm gonna put greater than 9. Above means greater than, right? Okay, so now we're just gonna solve and get x by itself. So we're just gonna do the math to get x by itself, so I'm going to subtract 11.074 from both sides. Somebody do the math for me. Alrighty, that should be 2.074.
Yes.
Divide both sides by negative 0.146. Aha! It happened. I just divided both sides by negative. What should happen to my my greater than symbol? It's gonna turn the other direction. So now this is gonna switch. And so now it's gonna be a less than symbol. And I know this is gonna be x over here because the negative 0.146, they both cancel out. All right, somebody tell me what this was on the calculator. 2.074 divided by negative 0.146. Oh, and this, look guys, I made a mistake. This should be negative. This 2.074 should be negative. So that should be a negative sign right there, because when I subtracted 9 minus that, it should be a negative 2.074. All righty, calculator, please. 14 point what? 045?
205.
205. 205. All righty. Did it say it wanted an x value, or does it, and again, let me restate the way we've got x can be all the numbers less than 14, and x is a what? Years, okay. So, look at what it says. For what years does the model indicate that the marriage is above 9? For what years? It didn't say how many years, it says for what years. What should I do with this 14? Add it to what? 1980. And the homework is going to say round to the nearest whole number. For years, it'll tell you to round to the nearest whole number. So I would leave this as 14.
Okay.
Okay? So that will be 14 plus 1980 is 1994. So, for what years is the marriage rate going to be less than 9? For years less than what? For the years less than 1994. The marriage rate is going to be above 9 for the years less than 1994. Okay, look at what the second half of that part of that section says. I want to know when the marriage rate was what? Below 8 marriages. What symbol should I use for below? Less than. Okay. Use the same exact inequality that we already had. I'm just rewriting it with the less than symbol. And then just work it out just like we did previously. Less than 8. All right, I'm going to subtract 11.074 from both sides. This cancels out, so I'm left with negative 0.146x. It should be x up there. Less than, what is that, negative 3.074?
Yes.
Divide both sides by negative 0.146. Does the symbol switch something?
Yes.
Yes, it does. We divided both sides by negative. So again, this symbol has to switch to the other direction. So now, instead of a less than symbol, it's going to be a greater than symbol. So x is greater than, all right, I need my calculator. 3.074 divided by 0.146 is?
Negative 21.05.
You said negative. Should be negative or positive?
Oh, positive, sorry.
21 point what?
0.54, sorry.
Okay, if I round that, it's going to round to the nearest whole year, which is going to be 21. So now I'm going to take that 21 and add it to what? 1980. So that's going to end up being the year what?
2001.
Is that 2001? Okay. So, what years is the marriage rate less than 8? For the years greater than 2001?
Yes.
Yes. Okay? So you got a chance to see it with the actual work where the symbol does switch. Yes.
And so if there was another inequality sign,
Mhm.
at this point is when you would flip it back.
When you say if there was another, what do you mean, like double?
If they were both greater than rather than last two.
Okay, so these, if both of these were greater than symbol?
If you had another number, I know it doesn't make sense in the context, but. you
Right
don't-
here, if I had another greater than symbol over here on this side and put another
Yes,
number?
that's only the case when you would flip it right.
Only when you had another symbol over here and another number. Correct, you would leave it just like it is. Right now, it's perfect. Got it. Alrighty, last one on this slide where we want to make sure, and then we'll jump to the homework. Alrighty, let's see if we understand the problem. Part of making sure you know how to do word problems is making sure you understand the problem. And also, while we're doing that, let me send the sign-in sheet around, because I almost forgot that I hadn't gave you the sign-in sheet yet. So while you guys are reading that problem, let me send you the sign-in sheet. Let's make sure we understand what you're reading. This is 335 class names. 220. All righty, there you go. All righty, I'm gonna read. The temperature, which we're calling T in Fahrenheit, inside a concert hall M minutes after a 40-minute power outage during a summer rock concert is given by T. T is the temperature, so the temperature equals 0.43 times M plus 76.8. Write and solve an inequality that describes when the temperature in the hall is not more than 85 degrees. All right, so let's stop and make sure we understand the problem. Yes?
Back to the other question, when it's 21.5 would it go up to 22?
It'll say round to the nearest whole year. So if it would have went, if that was 0.5, it would have went to 22.
Okay, thank you.
All right, so let's make sure we understand the problem. What are we talking about? The temperature where?
In the concert.
At the concert hall, okay? And what happened? Okay, so are you expecting it to get warmer if you at the concert and the air ain't working?
Yeah.
Okay, all right, so we in agreement, and they're trying to figure out, can we write an inequality statement that describes when the temperature in the hall is not more than 85 degrees? I need to know what that not more than means.
Less than
Or equal to 85 degrees. So they're trying to figure out how much time do we have trying to fix the AC so to keep people comfortable up to a certain temperature. We try not to let the temperature get over 85 degrees in the concert hall. Do you understand what a person who might be thinking is doing for this?
Yes.
Okay. How much time has already passed by since the air conditioner broke?
40 minutes.
40 minutes has already passed by. So we're trying to figure out how much more time in minutes do you have for that to be off, the AC is off, before it's going to reach 85 degrees. You got what we're trying to figure out? So now I'm just talking so we can just understand what the problem is. Temperature broke, air conditioner broke. We want to see how long it's going to take you to get 85 degrees. All right. So did they give us an equation to work with? Yeah. All right. So I'm going to push this one up and pull this one down and work off of this board. So I want to make sure that, are we going to need to use the inequality that they gave us, that T equals 0.4043? Are we going to need to use that?
Yeah.
Okay, all righty. So let's use it. So I'm going to write that on the board first. So here is 0.43 M plus 76.8. Now what's the M again?
minutes.
Say it again.
Minutes.
Say it again.
Minutes.
Say it one more time.
Minutes.
Tell me more.
Minutes.
Okay. Read the rest of what it says. What's M again?
Minutes.
After the 40 minutes, it's kind of like X is the number of years after 1980. M is the number of minutes after the 40 minutes has already passed. So it's not just that number of minutes, it's the number of minutes after the 40 minutes is all, the AC been off for 40 minutes already. So kind of keep that in mind as you're looking at this. All righty, so now I want to know, this represents the temperature, right?
Yes.
Okay, I want to know when the temperature is going to be what?
Less than or equal to 85.
Less than or equal to 85 degrees. All right, can we solve and get M by itself now?
Yes.
Okay, all righty. What should I do first?
Subtract 1.
All righty, from both sides. All righty, that cancels out. So now I've got 0.43 M is less than or equal to, that's a 2 here. Is that 8.2?
Yes.
Okay. So I got 0.43 M is less than or equal to 8.2. Divide both sides by 0.43. 0.43. I need a calculator. 8.2 divided by 0.43 is
19.069.
19.069. Okay? And this is minutes. When?
After 40.
Minutes after the 40-minute outage. Okay. So, how many more minutes do they have before the temperature is going to reach 85 degrees? 19 minutes or less, the temperature is going to reach 85 degrees. So, how many minutes total? Let me see. What does it say? We wrote the inequality. When it says write the inequality, guys, it just wants the first part that we first wrote on the board. And then it says solve it. That describes when the temperature in the hall is going to not be more than 85 degrees. Alrighty. So, can I leave this as my final answer, or should I add the 40 minutes that the AC already been out? Add the extra 40 minutes under here. So now I've got what? A total of 59 minutes before what? The temperature is going to get to what? 85 or more. It's going to get over 85 degrees after 59 minutes. So you got up to 59 minutes before the air going to go, it's going to get hot. It's going to get hot. All righty, questions? Okay. All righty. That's it for that section. We have officially finished 2.4. So now let's go to the homework. Where was the homework at? When is I need to look at the homework because I forgot what the due dates are. So we'll change that then. Usually I will always give you at least 3 days to do the homework. So if I teach it today, I'm not going to expect you to do it tonight. Yeah, I'll change anything that I really just taught you. I'm still expecting you to have 2 or 3 or 4 days to finish it. So I'll go change those. So you just have to let me know, because everybody, y'all ask me in different classes the same thing. I'm like, I don't know what the dates are due until I go look at them. So y'all have to tell me when they're due. And say it, in the video. I put a 2.3 out there today. Yes. I put one, yes I did, yeah. Gotcha. So, I'll go change the dates for that. So that's good. You don't have to worry. You'll have at least another 3 days to finish the homework and the quiz that's attached to it. Alrighty, so we'll finish that. Jump on My Math Lab for me for a second. Now, I know some of y'all already been in it. What y'all find that was looking a little interesting? Who been in the homework already? You saw something that didn't seem a little interesting.
Can you do one of them that has a fraction?
Yeah, that one.
That one. What number is that one?
I think that's 4.
Okay.
4 or 5.
All righty, number 4 it is. All right, number 4 on 2.4. Oh, hold on. Let me also stop this because I left this on for 14 hours and I couldn't post it.